Okay, so last time we were talking about whether we can realize the circuit or not. When we are talking about this circuit for the particular this course, we are talking about the passive circuit or the passive element based circuit, which is R, L, and C. Okay. Do we know what is the impedance of these uh, these elements? For resistive, it's R. For inductive, hmm, omega j omega L. And for this one, 1 by j omega c. If you look at these, maybe in terms of Laplace, there are all these roots of these particular elements are either on j omega axis or this side, right? It cannot be at this side, right? So we should avoid this particular area, which is known as right half plane, or we will not synthesize any element which will be negative. Negative element will not be synthesizable, right? So uh, that is what Hurwitz wants to say, that you should have P of S is real when S is real, and always you will have the real parts. But if it is uh, complex, then it has to be only on j omega axis. It should not be here and there. So for that, you need to do something here and there so that you can achieve those kind of roots. But before going towards a high level of synthesis, let's look at two examples. One is a green box, one is red box. So what do you think about the whether this is synthesizable or not, and this is synthesizable or not? What do you think about? As per first theory, it's on, like, it is on this side including j omega axis. So this is synthesizable with green box, and this is not synthesizable. This is the first theory. This is not sufficient to say that the system is synthesizable. This is the first theory, first point, that all the roots has to be on left half of the s plane, and including the j omega axis, because that's the marginal stable. And one more thing is, all the impedances of inductor and capacitor are either SL or maybe 1 by SC. So that is exactly lying on the j omega axis, right? It's not going to be somewhere else. There are some more properties are there. If we have, okay, where is it? Where is the Hurwitz? Okay, so if this is an equation which is h of s written in terms of numerator and denominator, maybe you can call it as transfer function. However, if this is the entries where all ai are associated with the numerator, all the coefficients ai has to be non-negative. There is one more thing: both the odd and even parts of a Hurwitz polynomial P of S have roots on the j omega axis only, to synthesize this using inductor and capacitor. Now, when I'm saying even part and odd part, let's assume that I'm writing this equation. So here all the even entries, we are going to call them as even entries and name it as m of s, and we are going to write this. Similarly, all the odd entries will be named as n of s is equal to 3s cube plus 2s, and then, right? This is how we are going to write down even and odd parts, and when we are solve them, the ultimate solution should be such that they will have only roots on j omega axis only. We have to modify it little bit here and there. We'll do that, but understand that both the odd and even parts have roots only on j omega axis, or purely real part. Purely real part will create resistance, and j omega axis will create inductor or capacitor. Right? So as a result of property 2, P of S is either even or odd. All roots are on the j omega axis. Right? It cannot go at other place. Okay, and for that we are going to one method of expansion which is known as continued fraction expansion, and through that we are going to write down the transfer function like this. Look, why it is important or why it is useful. If some function is given, I want to make the circuit out of it. If this is the transfer function given to you, can you make that by looking at by the observation? Just using R, L and C, you know that the resistance has impedance of R and Ls and 1 by Sc. Yeah, so how do you do that? Divide by what? Yeah, so adding to your theory, first of all, this theory will work when the numerator and denominator difference of degree is 1 or 0. If it is other than that, then we have to do something else. This is the easy example we have started with. That's why it's easy to like reformulate. And as you have suggested, we can divide this with S, which is going to give me this. And if this is transfer function, you can call this one as now what? Now what? By the way, whenever look, whenever there is an addition in impedance function, if you are saying plus sign in impedance function, you have to connect those two elements in series. But look at this, this is not just an impedance function, but this is 1 by something. So if this is admittance, then both the things has to be in parallel, right? So I can put this one, or this will be 1 Henry and this will be 1 by 2 farad. Remember to keep always units. Without units it's useless, right? By the way, sometimes what is happening, if you observe this equation, let's assume that this psi of S is an impedance which I want to create. So what is the unit of this one? This is Henry, right? Q1 Henry, and this is going to give you the impedance. This is impedance. But what about this one? Is it impedance or it's admittance? It's admittance because it's 1 by, and then you are writing something. Look at this. First part is impedance, and then you are converting that to 1 by something that is going to give you admittance entry. Again I am adding with impedance, again admittance. So it's a combination of impedance and admittance. That is what you need to formulate in your circuit. But when there is a function, or when we are writing some function which is output divided by input, or the input impedance, output impedance, or any port impedance, all the impedances are known as driving point impedance. We already talked about that, but you can call them as driving point impedance if you are interested in impedances. But sometimes what is happening, you are interested in admittance, so you are going to call them as driving point admittance. But sometimes where you have impedance and admittance together, you are going to call them as, do you know the name? Maybe the new name for you. Okay, it's known as immittance. It's a combination of admittance and impedance. So the function which is combination of both, we are going to call that one as emittance, right? So these are the three different definition, but all the way we are finding out some driving point function which might be impedance, admittance or emittance, right? Okay, so let's move further, because at the end we are going to make function which will look like this one, just to create a circuit. Okay, now let's find out whether my function is Hurwitz or not. If I want to find out Hurwitz function, I need to find out what are the even terms and odd terms. So even terms are all even entries, odd terms are all odd entries, right? So now what this Hurwitz suggests, you have to make division of these two so that I'll get the function which looks like this one. I have to make division by function. So those division are as follows. You need to divide, say, s raised to 4 plus 5s square plus 4. This is my m of s, and n of s is equal to s cube plus 3s. To find out the entries which look like the function which we have talked about, we need to divide the even entry by the odd one. So I'm dividing it. When I want to divide, I'm going to multiply this with s. So that will give me s raised to 4 plus 3s square, and I'll make the subtraction. So this will be 2s square plus 4, right? This I can write down as, so if I am making the division of these two functions, means m of s divided by n of s is equal to s plus s cube plus 3s divided by 2s square plus 4. Oh, sorry. Is it correct or? No, it has to be, if it is, let's say 10 by 8, so 8 ones are 8, so 2, so I can write down 1 plus, no, 8 by 2, right? Oh, sorry, 2 by 8, 2 by 8, right? So that is what I was writing here, that was correct, right? So I can write down this function. If I divide at the first entry, so you can see that this is s cube and s square. If I divide it with s, I'll get some s square entry. So I cannot realize it. I need to again divide it so that I'll get just the entry which will have only j omega axis entries, not two entries. So I'm again going to divide it, but when I'm going to divide it, I'm going to flip them. So this one will be divided with this entry. I'm taking this one here. When I'm dividing it, what I'm going to get? 2s, s divided by 2, that is going to give me s cube plus 2s, so 2s. Then again I need to flip it because this is becoming, okay, first of all it's divided by this one, so it has to be 1 by s by 2, right? Plus 2s divided by 2s square plus 4. Hmm? 3s minus, what do you say? Sorry, I here. Oh, okay. So this one is wrong. You mean to say? Okay, right? So then you have to again divide it with this one. So then you can do it with 2s. That will give you 2s square, and 4. 4 has to be divided by s. So this is 4 by s. So s by 4. So that is giving me, and this is u, right? Yep. So you need to check all the entries. If they are negative, it's not realizable, right? If they are negative, they are not realizable, And when we are writing this equation, it's equal to s plus 1 by s by 2 plus 1 by 2s plus 1 by s by 4, right? So this is the function when it is division of even and odd, which will be realizable. But our theory is not right now to synthesize it, but entry has to be positive to make sure that it's realizable. So with these positive entries, we can conclude that this function is Hurwitz and it's synthesizable. Okay. And by the way, this particular method is known as continued fraction expansion, through which we are finding all these entries. Okay, so can you tell me whether this is synthesizable or not, or Hurwitz or not? So what is M of S? Right? So you can divide right. So at the midpoint itself, you can say that this is not Hurwitz. Right? You can find other entries also if you want to find out. Right? So this is not Hurwitz. Is it there? You can see that it's negative entries. Right? So yeah.
What if this function is highest degree is odd?
Which one? F of S, you mean to say? This might be useful in future. Right now, it's just a mathematical function.
Sir, if degree highest degree is odd.
Highest degree is odd. Okay. It's okay. So you. Okay. So what? Yeah. Yeah. Then okay. Then you have to make it reverse way. You can make it n of s divided by m of s. In that case, yeah. You can make it any either of the way. It's not a problem. If that is the case, then you don't have to implement impedance, but it will be admittance. Right? Okay. So this was the first part of the realizability theory. But second part is known as positive real function, where you are finding out whether my system is positive real function or not. This is also second part. You need to check both, because in some complex like difficult equations where you will have the entries which is not realizable just with telling that with the Hurwitz it's realizable. You need to look at the positive real function also. Okay, so same chapter I am following, but this is second part of the chapter. Now positive real function is the one if it is denoted with f of s, then f if this Laplace operator is real, then f of sigma is also real. And similar to that, f of s is always greater than or equal to 0 when the real part of s is greater than or equal to 0. You can map all these Laplace entries to f of s as it is, because there will be some linear equation. Now there are some properties, those properties are already known to you, but it's mathematical properties which has been formed to the circuit theory, which says that if f of s has L times s, then L will be inductor and it will be real and positive number. If it is just a real number and positive, real and positive, then it's a resistance. And if it is k by s, k is real and positive, and it will be positive real function, but it will be capacitor and measured in farads. It has to be capital, right? These three things are already known to you, and these are the functions. Right now it's written in admittance. You can write down in impedance also, or you can write down in emittance also. Now there are some conditions we need to check, that f of s must have no poles in the right half plane. This is already known to us. This is the first condition. Second is, it has to be only simple poles. When I'm saying simple poles, I'm talking about just j omega axis. There should not be anything like sigma plus j omega. It has to be just j omega, because when I want to implement, let's say, inductor, it will be just ls. It will not be like something else. Like real part will not be there, or at least in our course we are not going to consider the real part. And when we are going to like solve the equations or real part of f of j omega, it will be greater than or equal to 0 for all omega. So these are the three conditions which we need to check to find out whether my function is positive real function or not. If it is positive real function, then I can synthesize it, and I'll synthesize it with some crude way, which you already know, and we have designed our circuit very recently, like using resistance and capacitance, right? Inductor and capacitor, we found out something like this, right? So this is from our basic knowledge, but afterwards there are two uh, two circuit designers came, and they analyzed the circuit. One guy is known as Coyer and one guy is known as Foster, and they have given two different techniques. One is known as Coyer 1 and one is called Coyer 2. This one is Foster 1 and one is called Foster 2. So they have some fixed way of writing function, and through which you can directly write down or you can draw the circuit directly using the function. So they have given some technique which are known as Coyer 1, Coyer 2, Foster 1, Foster 2. So this chapter will be like synthesized after completing this Coyer 1, Coyer 2 and Foster 1, Foster 2. Before that we are making positive real function just with our knowledge that what impedance or emittance will be coming in parallel or in series, right? Okay, so I want to test those three conditions, where all the poles should not be on right half plane. F of s must have simple poles only, which are only on j omega axis, and real part of that function has to be greater than or equal to 0 for all omega. So how to test that? So if you want to test it, check the denominator of for the Hurwitz property using continued fraction expansion. For that you need to divide odd function with even or even with odd, depending on which one is higher one, right? This has to be the first one, which is very easy, right? Second one is using partial fractions and checking their residues on the j omega axis. Now do you know what is, you have studied partial fraction method, right? You have studied residue also once I showed that, right? So you need to check that residues has to be positive and real, then this is working. And the third one can be checked by one technique where f of s is equal to p of s divided by q of s, and f of s can be written by two things. The numerator will have even entries which are known as m1 of s, and all the odd entries of p of s is known as n1 of s. m2 of s is even entries of q of s, and all the odd entries of q of s is n2 of s, right? Now if you have such situation and you have to solve the equation, or you have to make the equation which has real and imaginary part, this is what I want to distinguish, because the third condition says that real part of f of j omega has to be greater than or equal to 0. For that, what generally we are doing, we are multiplying with m2 minus n2 and divide it with same, right? This you must have done it, right? And when you are doing so, what you are going to get, it's m1 m2 minus m1 m2 plus n1 times m2 minus n1 n2 divided by m2 square minus n2 square, right? Where there might be two possibilities. One, if I am multiplying even entries with even, what is going to happen? Will it be even or odd? Right? It will be even, because if it is s square multiplied by s square, this is going to give me real part, right? It will not give me imaginary, because this is minus omega square multiplied by minus omega square will give me omega raised to 4. So it's real entry. So even multiplied by even is going to give me real entry. If I am multiplying odd with odd, what I am going to get? Real entry or imaginary? Real, right? You can take one example like s multiplied by s cube. So it's real. It will not be having uh, any function which will be multiplied by j, or it's imaginary. But if I am multiplying even with odd or odd with even, it's equal to imaginary. So even with even, odd with odd, I'll take them together, divide with m2 square minus n2 square. I call this entry as real entry and this entry as imaginary, right? So I need to find out real part of this one has to be greater than or equal to 0. This is what I need to find out, just to qualify my function as the positive real function. Is it going fast, or are you following? It's simple complex number, and just I am playing with that. Okay. Now, so this is even part of this one, and this is odd part of f of s. I'm going to call one of them is real, one of them is imaginary, and even part of this one has to be greater than or equal to 0. Okay. So I can say that this was the has to be 0. So for that, this part will be multiplied here. So it's sufficient to say that m1 m2 minus n1 n2, if that is greater than or equal to 0, the function is the whole function is greater than or equal to 0, right? You can say that. So the condition which coming at the end is known as m1 times m2 minus n1 times m2 has to be greater than or equal to 0 to meet third condition, which is equal to this one, right? Okay, so please keep this one in your mind. There are three conditions. One says that you have to find out the right half plane. Zero should not, pole should not be there, or the roots has to be on left half plane, right? So this is restricted one. Second one, you need to check her widths, and third one, the real part of f j omega has to be greater than or equal to 0. These are the three things you need to check to before you synthesize your circuit, or before you go for coil 1, coil 2, or anything. Generally, will not give like I'll not give any question which will not be realizable, but by mistake, if it is not realizable, you have to check that. Okay. So let's check the PR condition, or the positive real condition. When I'm writing PR, it's positive real function condition, right? So let's assume that two conditions are following. There is no problem. And here A and B are the number which are general number, or C, all three are the general number. We have to find out what will be the function. So if B equal to 0, then the situation is easy. If B equal to 0, the situation is easy. It's realizable. For C greater than 0, A greater than 0. If B equal to 0, this is one possible thing, right? You can synthesize this, right? If this is impedance function, you can write down its two admittances are in parallel, right? You can write down that. But if there is a case where I don't know what is the situation for A, B, and C, so I can write down m1 m2 minus n1 n2 has to be greater than or equal to 0. So what is m1 by the way here? A. What about n1? S, right? What about m2? S square plus c and b. When you are keeping these things in this equation, you are going to see that it's a s square plus c minus s square b is equal to, when s equal to j omega minus omega square a plus ac minus plus omega square b, where you can club these two together and you can make that omega square b minus a plus ac has to be greater than or equal to 0, right? So if b is lesser than a, then this function will be not positive real function, and it's not realizable. So b has to be greater than a, or if b equal to 0, then a should be equal to 0, right? If b equal to 0, then a also should be equal to 0 to realize this circuit, right? Okay. It makes sense, right? Okay. So here this is a conclusive remark that if it has to be greater than or equal to 0, or from the second equation b has to be greater than or equal to a. Now, can you check the PRF condition for this one and tell me whether it's positive real function or not? So you have to find out m1, n1, m2, n2. So what will be the m1? m2? So can you find out m1, m2 minus n1, n2 at s equal to j omega? Yeah, positive real, because b is greater than a and c is greater than 0, right? From here itself you can say that, because similar thing we have done it. Can you say something on this one, whether it's positive real function or not? m1 is equal to 1, n1 is equal to s, m2 is equal to, right? So now can you tell me whether the function is positive real function or not? This is my m1 m2 minus n1 n2, right? So this is negative entry, because omega itself will be always positive side. We are not going to talk about something which is non-causal, right? We are only going to talk about the causal system. So this will be not positive real function, right? Now let's talk about this one. Is it same? Oh, okay. It's a new question, right? So it's copied one. So whether it's realizable or not, I can see that B is lesser than A, C is greater than 0, no problem. So by here itself I can say that, because this is the commonly used transfer function if it is second order. Right? So by directly by looking at A and B, you can say that no, it's not positive real function. You can check with m1 m2 minus n1 n2. it will give the same answer, by the way, right? For the sanity check, you can check that B is less than A, so it's not working. Okay, till now all good, so no problem. If you know whether my system is Hurwitz and if it is positive real function, I can move further and I can synthesize my circuit. This was the first part, right? Okay, there is one more important understanding we need to have. If there is an impedance function and there are two impedances are in parallel, which is equal to z1 of s times z2 of s divided by z1 plus z2. So if z1 is Hurwitz and positive real function, or you can say that all positive real functions are Hurwitz, by the way. So if your function is PRF, then, and this is also PRF, then the parallel combination will be also PRF. Or you can say that if they are in series, that is also positive real function, right? And same thing is true for admittance and same thing is true for the emittance. So if it is combination of both, still if individual all the elements are positive real function, then all these things in total will be positive real function. And if they are positive real function, then and then you should follow our theory and you should draw the circuit. So this is what this whole paragraph is saying. Okay, so the basic philosophy behind the synthesis of driving point functions, either it is impedance or admittance, can be break up into positive real function z of s into a sum of positive real functions z1, z2 and zn of s, and then to synthesize these individual zi of s as elements of all overall network whose driving point impedance is this one. And in that case, all the impedances are coming in series. So it is z1, z2, z3, zn. This has to go to output side and this is input, right? Because it is in series. If it is in parallel, it has to be parallel. So parallel entry is difficult in impedance. So what we are doing, we convert this impedance into admittance with this plus entry, because then it will be in parallel. But we are not going to make parallel entry of impedance, series entry of admittance, because it will be easier for realizing same circuit elements, right? Okay, so now moving further, and let's call this driving point impedance as P of s divided by Q of s, which will have some even part, odd part, everything will be there in P of s and Q of s. When we are doing this with three different condition checking for positive real function, and when we are making for Hurwitz function, when we are making this division, we have to make sure that division will go till the end when the numerator and denominator will have the degree difference of 1 or 0. Actually you should reach 0, but with 1 itself you can say what is the what are the elements in your circuit, right? So you have to go till here. Okay, so consider the case where z of s has a pole at origin. So such system you can directly, so let's make some system which has if this is the case, means you have pole at origin, then you can rewrite this equation as 1 by s plus, and you have to find out this one. Can you do it for this one, for the using partial fraction method or whatever method you have learned? Or by observation you can tell. Minus 1, if it is minus, then look, this is not positive real function. This will not work. Look, the denominator is s plus 2. So if this is 1, so this will be s plus 2 plus how much I need, what quantity of values I need to make this 1. Minus 1. Okay. I choose the function which is not realizable, unfortunately. Okay. Right. So if it is realizable, and then you have to find out z1 and z2, and the first part is going to denote the capacitor, right? Similarly, if there is 0 at origin, what are you going to see? You are going to see the inductor, and rest of the part is in series when you are writing in plus. If the rest of the part is a constant term, then it's realizing the resistance, right? So these are the common things which already known to us, but we have not synthesized it. That's the only difference. But let's look at that. Our z1 and z2 are positive real function. From previous discussions, we know that z1 is equal to d by s. Z2 is of course it is also positive real function, because this is resistance which is positive. This is again a positive entry. So both are positive real function. Directly you can say that without looking at m1, m2 and other things. It will give same answer, by the way, right? So z of s must have no poles in the right half plane, and poles on imaginary axis must be real and positive, and the real part is greater than or equal to 0. This is what happening here. And you can draw the impedance realization using two things. Z1 of s is equal to d by s, and other one is resistance. Okay, so let's go to the real problem. If it is z of s equal to s square plus 2s by 6, plus 6 divided by s, that's s plus 3, then can you synthesize this? Assuming the fact that it's a positive real function. We are not going into detail. It's positive. Okay. However, if it is, look, however, if somebody is asking you to synthesize this circuit, your first, for the sanity check, you need to check that whether it's realizable or not. If it is realizable, then you should realize it, and that is only possible when it's positive real function. Right? You know the conditions, how to check that. Now, can you make this? So can you see pole at origin? If it is pole at origin, can you find out this A and B or whatever? Of course, you need to use partial fraction. This part will give me the capacitor. So how do you solve this, by the way? Can you check, Dinesh, can you check how people are solving this using partial fraction method? I don't know whether they should be knowing this. You must be expert of this, right? If you have any doubt, please ask my TS. They will help you. Himanshu, can you check what they are doing? I don't know. Yeah. So what is A?
is 2.
A is 2.
B is S.
So you can check that. 2s plus 3. So that's correct. So you know how to do it, right? Maybe sometimes it will be a complicated network where it might be a square, or all these techniques, right? Using residue also you can find out. This is actually the residue. All A and B are a residue. You have to find out the residues. How many got this answer? Can you raise your hand? How many got this answer? What about the last gentleman, Rohit? Yes or no? Why no? What are you doing? Are you in the right track, or because we have to do this one every time? Second part is all about synthesis, so you have to work with the complex number and partial fraction methods. Vijay, can you check with Rohit and yeah. So what are they doing? So those who cannot get the answer, please talk to your friends, and it's very easy. It's not complicated. It will take hardly 5 minutes to learn it. Okay. Okay. So now, okay. So first one, no problem, right? Can you see the capacitor? Is there anybody who cannot see the capacitor here? There is a capacitor of 1 by 2 farad, right? So there is a capacitor, no problem. But this entry is difficult, right? It's not in terms which we are doing, but you can see that the maximum degree between these two, like entry numerator and denominator, it's 0. If it is there, you can divide this by numerator with denominator, you will get this one, right? So can you draw the impedance function? Can you draw this? So there is a capacitor. So there is a capacitor of 1 by 2 farad. Do not forget to keep the unit. This will be the input 1, and I want to find out the driving point impedance of Z of S inside these two terminals. So what will be the next entry? Okay, so this becomes, by the way, admittance. So there are two entries, 1 and 3 by S. So this will be inductor and this will be admittance in mho. It's 1 mho. If you want to make it resistance, it has to be 1 by 1, so 1 ohm in parallel with inductor, which is 1 by 3 Henry. Right? So do not forget to keep these units. These are very important, right? So this function has impedance as well as admittance. So this is also known as immittance function. So if you are reading somewhere immittance function, then you have to understand this combination of both, right? Is there anybody who does not understand how this circuit is coming? Nakul, are you following? Or mine. Okay. So if all things are good, then there is no problem. Now, can you synthesize this one? Look at this. This is admittance function, not impedance function. It's admittance function. So in the entry where you can see that there is no pole at origin. This is unfortunate. There is no 0 at origin. And numerator and denominator, the degree is same. And you can say that if j omega equal to 0, or at DC, I am going to see 1 by 2 mho. This is third thing. If there is no pole at origin, there is no zero at origin, means there is some DC term. If both the degrees are same, right? So I can find out 1 by 2 means 1 by 2 plus some function. I need to find out. Are you following this or is it difficult? Nakul, you don't follow. Okay. So there are 2-3 things we need to see. Whether there is a pole at 0 or not. If it is 0, if it is available at 0, let's say something like this, then I am going to keep something a by s plus 2s by plus 4 and the b entry here. If this is not the case, and if there is an 0 at origin, might be, I can write down something here and other transfer function. So then this will indicate capacitor in admittance. If it is a by s, it's inductor in admittance. So these two things are not happening. Even as I told you, the degree of numerator and denominator is same, so difference is 0. I can divide it, but it's again giving me some function which is not easy to realize. So what I'm doing, I want to make this entry like 0 or it has to be removed. So what I'm doing, I'm finding out what is happening at DC. In such situation, you have to keep this frequency component as 0. So that is going to give me 2 by 4, or you can say that 1 by 2 y of j omega at omega equal to 0. Right? So at omega equal to 0, this is the case. What is the case in other frequencies? You need to find out that one. So can you give me that function? 3s divided by s plus 2. So it's s plus 2 plus 6s, so 7s plus 2. So that is the thing. Now I don't see anything, any entry over here, Nakul. So now I can divide this term because the degree of numerator and denominator are same, so I can divide it and I can rewrite this equation as follows. So now can you draw the circuit? If it is admittance, so this is, by the way, admittance whose unit is mho, not ohm. You have to convert it to ohm if you want to make it in ohm, right? Draw that.